Hi, this is Javin Kharod, a chemical engineer by profession, going to continue our today's topic, failure mode and effect analysis. Now what is that? Failure mode and effect analysis is the process. Review many company, assembly and the subsystem, possibly identify potential failure mode in a system that causes an effect. For each competent and failure mode and resulting effect of rest of system are recorded, specific failure mode effect analysis worksheet. There are numerous variations of such worksheet. FEMA can quantitative analysis, which can semi-quantitative basis, risk priority number model, related method, combined mathematical failure, the model statistic failure mode, ratio, database. It was the first highly structured systematic technique analysis. It was developed reliability engineer in late 1950s to study problems that might arise from the malfunction of military system. In FEMA is the first step, the system reliability study. Few different FEMA analysis exist as functional, design, process, software. Sometimes FEMA extended FMECA means failure mode, effect and critical analysis with the risk priority number and indicate critically. FEMA is the inductive reasoning, forward logic, single point of the failure analysis in the core task reliability engineer, safety engineer and quality engineer. The successful FEMA activity help identify potential failure mode based on experience with the similar product and process or based on common physics of the failure logic. It was widely used in development, manufacturing industries, various phases of the product life cycle, effect analysis required, studying consequences, the failure at different system level. Functional analysis need input determine the correct failure mode. The system level, both the function, FEMA, pieces part, FEMA and FEMA is used to structure mitigation, risk reduction based on either reducing severity, failure mode and effect, lowering the probability, failure or both. Now FEMA principle, full inductive and forward logic analysis. However, failure probability estimate reduced by understanding failure mechanism. Hence, FEMA may include information causes failure. Deductive analysis reduce the possibility occurrence by eliminating identify root causes. For more complicated scenario modeling, another type of reliability analysis may be considered. Example, fault tree analysis, deductive, backward logic, failure analysis that may handle multiple failure within item and external item include maintenance, logistics, higher functional system, FTA, use the basic failure and FEMA record all the effect summary for its input, basic events, interface hazard analysis, human error and analysis other added complications, scenario modeling. Now, the analysis should always start at sometime listening, function design, need to fulfill function, starting point, well done in FEMA and using function baseline program, yield of FEMA after all design. One of the possible solutions perform function and need to fulfill. FEMA can done concept design as well as detailed design, hardware, software, no matter how complex the design. Ground rule. Only one failure mode exists at the time. All input, including software command, item being analyzed and present at nominal value. All consumables are present sufficient quantity. Nominal power is available. Now benefit. A document method selecting design with high probability successful operation and safety. A documented uniform method accessing potential failure mechanism, failure mode and impact system operation. Resulting list of failure mode rank according seriousness of their impact likelihood occurrence. Early identification, single failure mode point and system interface problem which may critical mission success and safety. They also provide method verifying switching between redundant element and not jeopardize by postulating single failure. An effect method evaluate effect, postulated changes, design and operation procedure, mission success and safety. A basis in fight, troubleshooting, procedure and locating the performance, monitoring, fault detection device and criteria for early planning and test. Now failure mode. A specific manner way in which failure occurs. Terms of failure of part, competent function, equipment subsystem, system under investigation, depending type of FEMA perform failure mode, and describe various level of detail. Place FEMA will focus detail part component failure mode at fully fractured or deformed axle, electric contact, stuck open, stuck salt, or functional FEMA will focus functional failure mode. These may general such as no function, overfunction, underfunction, intermediate function, unintended function, and more detail and specific equipment analysis will focus process failure mode, such as insulting the ball drill bit. Now, detect requirement design, process quality control, and handling part of application, which underlying causes subsequent cause, and the process is lead to failure mode. Certain time of failure mode may have more causes. Example, fatigue of corrosion, structural beam. The corrosion is the electric contact, is failure mechanism itself failure mode. Related failure mode is a full fracture, structural beam, or open electric contact. Initial causes might have been improper application, corrosion protection, and abnormal various input. Another possibility fail system. Failure effect. Immediate consequences. Failure operation. More generally need to customer use and should fulfill function now is lost or not fully fulfilled. Inadequate level, bill of material and functional breakdown identified system level. Thereby, item complexity increase level are closer to the failure effect apply to item under analysis. Next higher level effect in failure effect as it applies. Next higher identify level and effect. Failure effect highest intended level to total system. Now means the detection of the failure mode, maintenance, operated, build, detection system include estimate, dormancy period, if applicable, probability. Now, the likelihood of the failure occurring, risk priority number, severity into probability, even occurring, and detection probability, even would not detect before use were aware of. Severity. Consequences failure mode. Severity consider worst potential consequences. Failure determine degree of injury, property damage, system damage, time lost, and repair and the failure. Remark mitigation and action. Now probability. We see according to rating and meaning. First, extremely unlike, virtually impossible, no known occurrence of similar product process with many running hours. Remote, relative few failure. Occasional failure. Reasonably possible, repeated failure. And frequent failure is almost inevitable. Now, severity. They are rating and meaning. First, no relevant effect on reliability of the set. Second, very minor, no damage, no injury, only result maintenance action. Third, minor, low damage, light industries affect very little system, noticeable average customer. Fourth, critical, loss of primary function, loss of all safety margin, failure away, catastrophe, several damage, several injury, possible death. And fifth, catastrophic product become inappropriate. The failure may result complete unsafe operation and possible multiple deaths. Now, according to rating, first indicate certain fault will count on that. Second, almost certain. Third, high. Fourth, signify moderate. Fifth signifies low, and sixth one represents fault is undetected, operator or maintained. Now, dormancy of the period, average time, the failure mode, undetected may be entered, known for example. Second, auto-detected by maintenance computer. 8 hours detected by turnaround inspection. 2 months detected by scheduled maintenance block X. 2 years detected by overhaul task X. Indication. Now, unintended failure mode allows system remain safe, working step. Second failure, situation should explore, determine whether not indicate, will evident all operator and corrective action may be should take. Normal, indication take, evident operator when system equipment is operating normal. Abnormal, indication take, evident operator when system has malfunction or failed. Incorrect, anomalous indication operator due to malfunction failure. Indicator, instrument, sensing device, visual, audible, warning devices, etc. Now performance, coverage, analysis and the process monitor. This type analysis useful determine effective test procedure or detection latent dormant fault. Method use accomplish involve examination applicable failure mode determine whether not effect are detect determine percent failure and applicable failure which detected possibly the detection means itself failed identify should accounted coverage analysis limiting factor coverage cannot rely the detection means availability inclusive detection coverage FEMA can be each individual failure which is effect category being separate in category due to detection coverage possibility. Another way include detection coverage for the fault tree analysis and conversely assume all whole coverage due to latent failure detection method and detection all failure assign failure effect category function. FEMA can revise necessary cases where conservative assumption does not allow prevent probability requirement to be met. Risk is combination, effect probability and severity, where probability and severity include effect, non-detectability, dormancy time, and this may influence effect probability failure. Worst case, effect severity, effect calculation, easy, all cases, such that multiple scenarios they are possible and detectability play crucible role for redundant system in case fault-free analysis and event tree may intended determine exact probability and risk level. Primary risk level can select base risk matrix based on higher risk level and mitigation needed to provide evidence and lower risk expectable level. Now FEMA, when product and process is being designed, when existing product process is applied novel way, before developing control plan and procedure, new and redesigned process, when trying to improve existing product process service, when analyze failure in existing product process service, and periodically regular throughput lifetime product process and services. FEMA should update when new cycle begins. Changes are made operating conditions. Change is made by design. New regulations are instituted. Customer feedback indicate a problem. Development system requirement minimize likelihood failure. Development design test system observe failure have been estimated risk reduce expectable level. Development evaluation diagnosis system to help design choice advantage catalyst for teamwork and idea exchange between the functions, collect information, reduce future failure, capture engineering knowledge, early identification and elimination potential failure, emphasize problem prevention, fulfill legal requirements, improve company image and competitiveness, improve productivity, improve quality, reliability, safety product process, increase satisfaction, maximize profit, minimum late changes and associate costs, reduce impact, company profit margin, reduce system development, time and cost, reduce possibility, same kind failure in future, and reduce potential for warranty concern. Now limitation. While failure mode effect analysis identify important hazard in a system which resulted comprehensive and approach limitation, healthcare, FEMA and other risk assessment method include structure, what if technique and response approach have been found. Limited validity when used in isolation. Challenges around scope and organization boundary appear. Major factor, the lack of validity. Okay guys, this is about failure mode effect analysis topic. I hope you get sufficient knowledge after watching this video. Next Sunday, we have covered some another chemical engineering topic. Still then, goodbye. Do take good care of yourself.